Are you using AI or has AI taken over you? Hello there, I am Mr. AYP and I am your narrator for this video. This video was created by a human with the support of AI technology. It features a variety of demo tracks. Sit back, relax, and enjoy the experience. In a world where artificial intelligence can write code, compose music, and even mimic human creativity, you might ask, why bother learning at all? Isn't the machine supposed to do it for us? Are you relying on AI to do everything for you? Or are you leveraging it to amplify your skills? Let's talk music as an example. This man wants to make a song. He opens an AI music generator, clicks Create. Yet, he has no idea how it works. Just hoping it sounds good. However, this guy has got a melody in mind. He plays a few notes on MIDI keyboard and uses AI to harmonize and mix. He knows the basics and uses AI to speed up the process. The first person is outsourcing creativity. The second person is collaborating with the AI. AI can generate melodies, harmonies, even entire tracks. In this demonstration, I will show you the process of creating music using SUNO. Simply provide a prompt, and the AI will generate a musical composition instantly. This is the music generated by SUNO. The result produced by SUNO is truly impressive. But music isn't just math, it's emotion, storytelling, and soul. Here's how a human producer can craft basic music demos from scratch. Let's say I want to create an uplifting, energetic piano house-like music, and this is the example that I have came up with. Here's what it sounds like. The very first step is to create a draft tone using simple sounds like basic piano. Find a place where you can focus on brainstorming ideas, forget all the music that you have ever heard of before, being in the present, and imagine any random tone. Here is the initial draft of this project. Before I show you how I build this project, let's check out some essential tools. First is the 7-band parametric equalizer. You can adjust the frequency spectrum with this. Here is how it looks like. If you want to capture the sample's upper frequencies, adjust the knobs on the right side of the spectrum as shown. Here's what it sounds like. If instead, you want the lower end of the spectrum to stand out, adjust the knobs on the left side as shown. Here's what it sounds like. Next is the filter. There are all kinds of filters and plugins available, The one that I am about to show here is called the DALL-E filter. You can adjust the intensity of volume or panning of the sample. I use a chord progression made with hypersaw sound as an example. Here is the original 16 beats interval, for beats per chord, without the DALL-E filter applied. Now, our music has a 4/4 time, which means that each measure, or bar, contains 4 beats, and each beat is a quarter note in duration. We set the subdivision of interval as x16 and adjust the chart of volume level, and here's what it sounds like. Next, we change the subdivision as x2, that means the filter applies for each 8-beat interval, and adjust the chart of volume level again, and here's what it sounds like. Now, we will try out the pan option. You will notice that the sound pans between the left and right speaker. Here's what it sounds like. Next, we have the mixer. You can adjust the volumes and effects for each sound and sample in the project. Furthermore, we have the tool called automation. You can automate all sorts of effects. In here, I have automated the cutoff level of a sound sample, such that the sound's intensity changes based on the charts. Here is an example, check it out. We have now covered the 7-band parametric equalizer, the DALL-E filter, the mixer, and the automation tools. We have all the tools we need to create this sample music. I'd like to present the sound and bass arrangement for this project. First, the white noise. It fills out the mid to upper level of the frequency spectrum and create a sense of fullness to the music. Listen to it. Next, we have the bass drums. It is essential to have kicks, toms, hi-hats and snares to create engaging beats. Use a metronome, which produces steady pulse according to the tempo, to ensure that the beats play in time, or off the time whenever necessary. Here is how the bass drum is arranged. The key aspects of creating engaging bass drums are: 1. Add varieties to the kick, snare and hi-hat sequences. 2. Change the volume for each note to create rhythm and diversity for your music, and 3. Create different patterns for various purposes, for example, drum beats for build-up, drum beats for the chorus, drum beats for the introduction, etc. Next, I will show you various sounds and samples used for the project. We have electronic piano named Mental to provide supporting tones. We have viola staccato to provide supporting tones. We have hypersaw heaven that is combined with DALL-E filter to provide wavy supporting tones. We have deep reese to provide an ambient sound. We have PAD Kennyite FM to provide a weak ambient sound that covers the lower frequency spectrum. We have Electronite to provide a supporting tone which is different than the main melody. We have Acoustic Bass 3 to provide supporting tones. we have fluffy flex, support. It is used to create an interesting tone to introduce the main melody. Now, here is the sound that provides the lead tone, which is named Cosmic Quest. Lastly, I have created two important piano chord progressions to support the lead tone. I use the Yamaha C7 sound here. Here is the final result without any further processing. In this short tutorial, I have not covered topics like sound engineering, final adjustments or mastering, etc. Partly because I am just a bedroom, amateur music lover, and I am in no position to explain professional music making. But the point is, learning music theory, mastering instruments, and understanding production techniques give artists the power to shape AI output into something truly meaningful. Yes, anyone could just click a button and let AI do everything. But once you know how to select and use sounds, layer drums, and use various plugins, etc., you can use AI to suggest chord progressions, clean up timing, and ultimately, you are in control of the project and you have enough knowledge to steer the progression of the project into your intended direction. Now that's an effective collaboration. You are still the artist, and AI is just your assistant. Now let's talk about coding with AI. If I say, build me a website, and copy-paste whatever AI spits out, I'm not really a developer. I'm a copy-paster with a dream. But if I understand the logic, I can use AI to refactor, debug, or even generate boilerplate code. That's not cheating, that's efficiency. Real innovation comes from human insight. Knowing how the code works lets you ask better questions, design smarter systems, and push boundaries AI hasn't imagined yet. If you don't have any prior background in competitive programming, I would like to show you how to think systematically to solve coding problems by using one example. In this example, you will learn basic problem-solving skills and brute force algorithms, common paradigms like binary search and greedy algorithms, basic data structures and complexity analysis. Let's dive in. I will give you 10 seconds to read the paraphrased question statement, or you can pause the video. This question is taken from LeetCode. Let's understand the problem by going through a sample test case swiftly together. Let's say we have the array hours equals to 11, 12, 5, 1, 5, 4, and 10. The answer is 3. We can check every possible continuous subarrays, and now, pay close attention to the subarray enclosed by the rectangle with thick black borders. This subarrays contains the numbers 11, 12, and 5. The number of hours that is more than 8 is 2, which are 11 and 12, those are named as tiring days, and the number of hours that is less than or equal to 8 is 1, which is 5. The number of tiring days is strictly more than the number of non-tiring days. Therefore, this is the answer with a length of 3, there is no other valid interval which has a longer length than this. Here is the approach to solve this problem. First, we will rephase the problem, next, we figure out the main mechanisms, third, we handle the edge cases, and finally, we can implement the solution. We will further rephase the question statement into even simplistic terms. To make everything easier, we can just let hours that are larger than 8 as 1, and let hours less than or equal to 8 as -1. Under such description, we know that the interval is valid if the sum of values of the subarray is more than 0. Now, let's refer to our example test case again. We convert all the hours into ones and negative ones. Look at the interval enclosed by the rectangle again. We now have 1, 1, and minus 1. The sum of hours is 1 plus 1 minus 1 is equal to 1, that means the number of tiring days is more than the number of non-tiring days. You can see that rephasing problems is itself a skill to master. By articulating the problem statement in more straightforward terms, one can more precisely discern the underlying issue and formulate effective solutions. Next, we shall try to figure out the main mechanisms to solve the problem. At this stage, you should ask effective questions. For example, you may ask, how to find subarray sums quickly. This is the fun part, because your mind will be wandering around, trying to brainstorm new ideas. At the beginning, you would try to come up with a brute force solution. A brute force solution systematically tries all possible options to find the correct answer, often without optimization. Here, I came up with a brute force solution. Assume that we label the positions of the array using numbers, with the first slot as 0, second slot as 1, and so on. For each possible ending position, let us call it I scan for all possible starting positions of the subarray. We calculate the subarray sums by scanning the numbers between the starting position and the ending position I. We then check whether the subarray sum is larger than 0. If it is larger than 0, we update a variable which stores the current longest possible valid subarray length. For every possible ending position, we have a number of starting positions to check. If the array ends at position 0, 0 itself is the only possible starting position. But let's say the ending position is 5, then the starting positions can be 0, 1, 2, 3, 4, and 5. There are 6 possible starting positions. The last index of the array is n-1. Why? Because the first index starts with 0. We know that at the index n-1, there are n-1 plus 1 equals n starting positions to check. As the result, there are 1 plus 2 plus 3, plus all the way to n possible starting positions to check. You can simplify this sum sequence into a general formula. Let S(n) equals to that sum sequence. If you add S(n) 2 times, you can get n pairs of n plus 1. Therefore, S(n) plus S(n) equals to n times n plus 1. Therefore, S(n) equals to n times n plus 1, divided by 2. Formulating math formulas is yet another skill to master. If you are creative, you can discover shortcuts to solve many other problems, and reveal hidden patterns for deeper analysis. Now, n is the size of the array, S(n) is the formula to calculate the number of scans needed to execute the brute force algorithm. If n is large, let's say 100,000, the value S(n) is very large, which is 500,005,0000. A modern computer cannot handle that many operations within seconds. Since time limit is enforced on LeetCode, if you submit a solution using brute force methods, you will receive the time limit exceeded verdict from the judge. So how to solve the problem effectively? In this video, I will suggest one way to solve it. Before we dive into my algorithm, let's first understand what binary search is. Binary search works on an ordered array, such that values in the array are sorted from small to big. I have created an example. Consider an ordered array with numbers 1, 7, 10, 67, 100, 187, 210, 400, 1000. We want to find a value that is larger than or equal to 341. We will create 2 variables, L and R, which represents positions. Let L equals to 0 and R equals to 8, the leftmost and the rightmost positions respectively. Binary search works by calculating midpoint m for each round, and check the value at position m. M is calculated by L plus R divided by 2. We check the value at position m using some Boolean logic, then we update L or R to search for the required value within a smaller range, until the range size is less than or equal to 1. The 1 required value is usually there. We will walk through the searching process using our example. Here is a textual explanation of the scanning process. You may pause the video to read it, or you can watch a visual presentation. Here is the visual presentation. In round 1, L equals to 0 and R equals to 8. The midpoint m is 0 plus 8 divided by 2, which is 4. The value at position 4 is 100. 100 is less than 341, Since the array is ordered, we know that all values on or before position 4 must be less than or equal to 341. Therefore, we skip the checking. We update the index L as 5. In round 2, L equals 5 and R equals 8. 5 plus 8 divided by 2 is 6.5. We take the floor of the result and M equals to 6. The value at position 6 is 210. Again, it is less than 341, so we set L equals 7. In round 3, L equals 7 and R equals 8. 7 plus 8 divided by 2 is 7.5. We take the floor again and M equals to 7. The value at position 7 is 400, which is larger than 341. Since we want to find the first possible value from the left such that it is larger than 341, we know that any value that is on or after position 7 must be larger than 341. So, we update R equals to 6. In round 4, L equals 7 and R equals 6. The ending index is earlier than the starting index, which is impossible. We stop the computation. After the execution, we know that 400 is our best answer. The number of operations needed, or so-called time complexity, to conduct a binary search is around log n divided by log 2. You can search online for the proof or ask AI for the answer. I would like you to think about how to implement this in code, and what are the edge cases. Now, you understand what is binary search. Let's see how can we apply this to solve our problem. I have a proposed algorithm. For each position of the array, use binary search to find some specific starting index and calculate the subarray sums. You may read the text shown on the slides. My proposed algorithm may look slightly confusing, but let me demonstrate my idea using a simple example. We have this example array with numbers -1, -1, -1, -1, -1, -1, -1, -1. Next, we calculate a specific subarray sum for each position. For each position, we calculate a subarray sum that always start from position 0. For example, for a subarray that starts from position 0 and ends at position 4, you have numbers -1, -1, -1, -1, and 1. The sum of this subarray is -1. Now, what does selected leftmost index mean? Here is my definition to it. There's a lot of words, but stay with me, it is easy to understand with an example. First, we scan the array starting from position 0. The subarray sum that starts and ends at 0 is -1. Notice that it is the very first time -1 ever appears as a negative subarray sum so far. So, we store -1 into some value holder, and we store the information that the sum of -1 first appears at position 0 into another value holder as well. In the next position, at position 1, the subarray sum between position 0 and position 1 is -2. Notice that it is the first time -2 ever appears as a negative subarray sum so far. So, we store -2 into some value holder, and we store the information that the sum of -2 first appears at position 1 into another value holder as well. We keep looping the array from left to right until we reach position 8. We have defined 2 value holders to store information. So far, one value holder, let's name it as an ordered set, has stored -1 and -2. And the second value holder, let's name it as a map, has stored the following pairs of information: subarray sum of -1 first appears at position 0, and subarray sum of -2 first appears at position 1. Okay, you may notice that I have mentioned an ordered set and a map. Let's learn about those value holders, or in other words, data structures. An ordered set stores values without duplicates, and all values are ordered. A map stores key-value pairs. Each key is unique, and is associated with a value. For more information, please ask AI or conduct an online search. We have a critical observation here. I am about to explain it using simple examples, but if you need some time to read it, please pause the video. Let's say we have an array storing 4 -1s. The subarray sum between position 0 and 2 is -3, and the subarray sum between position 0 and 3 is -4. Obviously, -3 is larger than -4. Why is this important? Because when a negative subarray sum first emerges in the array, it represents the smallest negative sum encountered so far, starting from position 0. My observation is obviously true, and the same fact applies even when the array contains not only -1s but also 1s. If you are not convinced, I recommend you take out a piece of paper with a pen, sketch some diagrams yourself and find it out. Stay with me as the mystery is about to be unfolded. We can use this fact to find the longest possible valid subarray. We now get back to our example. Remember that when we are at position 8, the ordered set stores -1 and -2, and the map store the pairs of information that subarray sum of -1 first appears at position 0, and subarray sum of -2 first appears at position 1. The subarray sum from position 0 to 8 is -1. We use binary search to find the largest negative subarray sum possible, such that the sum is just less than -1. In this case, we have -2. We now check the map, and we know that -2 first appears at position 1, so, we cancel out their sums by calculating -1 minus -2. The result is 1. That means, the subarray between position 2 and 8 has a positive sum of 1, that means number of ones is more than the number of negative ones, such that the number of tiring days is more than the number of non-tiring days, and it is the longest possible valid subarray that ends at position 8. You might wonder, how about other negative subarray sums like -3, -4? By cancelling out the subarray sum with -1, the result is still positive. But, do you remember our observations? Every time we see a new negative subarray sum scanning from the left, it must be the current smallest possible negative subarray sum, and, it is the leftmost index possible. Any other negative subarray sums that is even smaller than it must appear at an index to the right of it. In our question, we want to find the longest valid subarray. Therefore, we want to find, given the current ending index, the leftmost starting index possible. Therefore, you want to find the leftmost index, such that after the subarray sum has been cancelled out, the resultant subarray sum is positive. If you need some time to understand the beauty of it, take your time and pause the video. Congratulations, you have just witnessed the beauty of greedy algorithms. Greedy algorithm is like a simplified rule set to handle problems which always works because of the proof we have. In this case, checking the positions of the first appearance of smallest subarray sums for each position scanning from left to right only is sufficient enough for us to find the longest well-performing interval for each position. You do not need to check for all possible starting positions for each ending position. Now, let's think about the edge cases. Edge cases refer to some possible scenarios that our main logic has not covered. There is one obvious edge case. What if the subarray sum is already positive? In other words, the subarray starting from position 0 already has a positive sum, there is no need to cancel out any prior subarrays. There is one way to handle it. Just insert 0 into the ordered set and insert the mapping of 0 to the position -1 into the map. Let's go through an example. Suppose we have an array with numbers 1, 1, -1, 1, and 1. At position 4, the subarray sum from position 0 to 4 is 1 plus 1 minus 1 plus 1 plus 1 is equal to 3. 3 is already positive. Since we have inserted 0 into the set, by using binary search, we find that the largest possible sum such that the value is smaller than 3 is 0. Since we have inserted the mapping of 0 and -1 into the map, we now calculate position 4 minus -1 which equals to 5, 5 is the length of the entire array. We have now created an algorithm that is more efficient than the brute force algorithm. Let's try to implement it. Before we produce the actual code, we can create a detailed draft called the pseudocode. You may pause the video and read the pseudocode. Next, here is a C++ implementation of the idea by me, Mr. AYP. Feel free to read my code or even try to execute it. If you do not know the specifics of the language, you can always consult AI tools or conduct an online search for the C++ documentations. In fact, there exists an even better solution. To know more, I encourage you to search for this LeetCode problem yourself and read other people's solutions. You can always generate the code using any AI tools available to you. However, when you rely on AI without understanding, you're at its mercy. But when you leverage it with skill, you stay in control. AI is a tool, not a replacement. Not a shortcut for learning. It's like a calculator, you still need to know math. So, to end this video, ask yourself, are you pressing buttons and hoping for magic? Or are you the magician, using AI as your wand? In the age of AI, learning isn't less important, it's more important. Because the future belongs not to those who rely on machines, but to those who know how to lead them. Keep learning. Stay curious. Create boldly. If you like this video, hit that like and subscribe button and stay tuned. This is the AYP channel.